Okay, now I'm going to start to talk about the scalar and vector. So what's the scalar, what's the vector? Basically, the scalar is any quantity, any value that you can just define it by the number, like the mass. You just say that the mass is, for example, 10 kilogram. That's it. So there's nothing else you need to define that value. If you define to one value, the only things you need is only a value, just one value. That's a scalar. But what about a vector? The vector is unlike the scalar. It has the value or magnitude, and it has a direction, like the velocity. So we know that, for example, velocity is, when we said that car moving with the 5 kilometer per hour or 5 miles per hour, there's two quantities. First of all, there is the magnitude of the velocity, and second is which direction it's heading. So you need both of them. That's how the vector works. So if we want to say that in the simple word for any vector, I want to talk about a vector. For example, that vector has two main properties. One of them is its magnitude, which is shown by its size, and the other one is its direction, which shows by this angle. So what magnitude it has, what direction it has, and that's how we're going to define that. The force, which is the one unit we are going to use a lot in the statics, is vector. So it has both magnitude and direction, and both of them are important. So here I very quickly go over the very basic properties of the vector and how we are working with the vector, and then we can move on to other topics. So one of the very first things that we have is that what we multiply a vector by a scalar. So if I multiply, for example, assume that I have a vector here, and if I multiply it by, for example, 0.5, it's going to just make that vector half of what I have here. So if I multiply it by a scalar, it's just going to change its size. So it's going to be half of it. But what about if I multiply it by negative, for example, 1? If it's going to be I times by negative 1, not only its magnitude change, also its direction change. So if I multiply this vector with, let's put, for example, this vector as, I don't know, f. So it's the f times, and then it's f times negative 1. This time is going to be like that. So the magnitude is the same because it's then 1, but the direction is different because we have the negative sign here. So it's how that it works. So if it's positive, it has the same direction, and if it's negative, it has the opposite direction, and the value the value of the scalar is actually how we are going to magnify it or make it shorter. So change the magnitude. The other parts that how we are going to add two vector together. So there are to add the vector together, there are two different methods. One of them is that assume that we have like that. So what we are going to do is that we draw line parallel to each of those two vectors, and then we connect them. So if this is the f1, and this is the f2, and this is going to be r. So it's the resultant force of that too. This is one way of finding so r here is f1 plus f2 in vector format. So if we add them together, the other way of doing that, again, assume I have these two vectors and want to add them, I'm going to put it in the triangle. So assume this is the f1, and then I put the f2 here, and then I connect the start to the end, and that's going to be R. So it's the very same thing, just two methods of doing that. Either way, we draw this parallel line and go here, or we go like the triangle and start from the start of the first one and connect it to the end of the second one. So we get that triangle here again. One thing that make sure that you know that f1 plus f2 is the same as f2 plus f1, so it doesn't matter which one is first, which one is second, so it doesn't matter. It's always the result of adding two vectors is going to be the same. For the subtraction, if you want to subtract two vectors from each other, so for example, assume I have a this is one vector, this is the second vector, so this is f1 and this is f2. And if I want to say f1 minus f2, I can write it as a f1 plus negative f2, and then add these two together. So if you remember, so the f1 is gonna stay the f1, so we're gonna put it here. That's the f1, and then the f2, it's times by -1. So its direction is gonna be changed, but its magnitude is gonna stay the same. So it's gonna be like this. So it's gonna be negative f2. And then we can use the rule as we had before. And it's going to be R, which is f1 minus f2. That we use it for our calculation. So that's basically how we add them or we subtract vector from each other. And basically this one is the very same as the other ones, no difference between them. The same way that we have them, we also can resolve a vector on any axis that we are given. So we can, for example, let's say that I have for example, vector R, and then I have two axes, any axis that you want, any two axes that you have. I can assume I have the axis like this. So it's going to be U and V. I have U and V axis, and then I want to see how these forces reflect on these two axes, what are the components of these forces on these two axes, so I can decompose it. To do that, again, from the tip of that vector, we draw the line parallel to each axis. So from here we start to draw the line parallel to this axis, and from here we draw the line parallel to the U axis, and then we have these two vectors. So this is going to be R along U, along V, sorry, and this is going to be R along U. So if you add RU plus RV, is going to be a R, in other way, that R is equal to RU plus RV. So that's how we are going to decompose it. So it doesn't matter how these U and V vector are or what are the angle between them. Doesn't matter. It only you just draw two parallel lines and then project the vector on those new axes. There are two other laws that is going to be really helpful when we are working with the vector. So let me clean here. Those laws are cosine law and sine law. To consider that, assume that we have, for example, this is f1, or let's put it here to make it less confusing. So assume this is f1, this is f2, and here's the resultant force R. No. And assume this one's gonna be alpha, this one's gonna be beta, and this one's gonna be gamma. So the cosine law says that the magnitude of R is f1 squared plus f2 squared minus 2 f1 f2 cosine gamma. So this is how we can calculate the length of the vector R. So this is the vector R, and we can calculate that length. The other one is the sine law, which says that the magnitude of each vector divided by the sine of the opposite angle is equal to each other. Other word, the f1 divided by sine alpha is equal to f2, and the opposite angle is beta, is sine beta is equal to R, and the angle opposite of that is sine gamma. So these two laws, so it's the cosine line and sine line. So we can use these two laws, basically calculate the magnitude and the direction of resultant forces when we have two forces added together. So I'm gonna just do a very quick example, simple example to show that how we are gonna use this. Assume that we have two vectors. So assume that we have two vectors. So if this is a x-axis and this is the y-axis, and we have two vector here and one vector here, and assume this is going to be 30 degrees, this is going to be 15 degrees, and this is going to be let's make sure that yeah, this is smaller, so it's going to be F1 is 50 Newton, and that's the F2 is is 100 Newton, and want to find out the resultant forces for these two forces. Again, the simple way of what we have done before, we go parallel, and we find the result, the R. So here we want to find the magnitude and the angle of the R compared to the x direction, x-axis. So before we are doing that, we have to find some of the angle in this form that we have. One thing that very easily we can find is this angle. So this angle is the 90 degrees, which is this total, minus 30 minus 40. So 15 minus 30 minus 15, which comes to 45 degrees. So that's 45 degrees. And this is exactly the same as here. So it's going to be also 45 degrees there. The other angle we can find is this one. We know that the total of, we have any shape that we have, any shape that has 4 sides, the total internal angle is 360. So we know that the total internal angle is 360 degrees. And we know 245 degrees we get, we subtract that. So minus 2 times 45. So if the total is 360, and I subtract this and subtract that, these two remain. So whatever remains is this and this. If I divide it by 2, is the angle of that, which is going to be 135 degrees. Again, this one and this angle are the same, so this one is also going to be 135 degrees. They are the same. Now that we have them, I'm going to write them as a triangle, draw them as a triangle, and then we do the calculation. So if I draw them, I'm going to keep the F1 where it is and add the F2 at the end of that. So it's going to be F1, and then I have F2. Let's write the F1 here so it's a bit more clear. F1, and then I have R going from here to here, and the angle we know is, through the angle we have here, we know that angle is 135 degrees. That's what we know. So we are going to use that cosine law and sine law to find out that magnitude and the angle. So if we come here and I start to, let's start with the cosine law. The first one that we have it, we already have it right here. So the cosine law for here, the magnitude of the R is going to be F1 plus F1 square plus F2 square minus 2F1 F2 cosine gamma. So F1 is going to be 50 square plus 100 square minus 2 times 50 times 100 times cosine 135. So the magnitude of R would be 139.9 Newton. So that's the magnitude of R. Then we need to find this angle as well, this angle here, which is, I'm gonna call it beta. We need to find that angle as well, because we need to know the direction of the R, not only the magnitude, also the direction. To find that angle, we use the sine law. And if you look at that, in sine law, we have F2 magnitude, we have R, we have sine gamma, and we want to find sine beta. So we can just use this part and do the calculation. In other words, we can say F2 divided by sine beta is equal to R divided by sine gamma. So I'm gonna erase this part. So the F2 is 100 Newton divided by sine beta, which is what we want to find, is equal to R, which is 139.9 divided by sine gamma, which is 135 degrees. And you cross multiplication and then use the arc sine to calculate the beta. So the beta would comes out as 30 degrees, 30.36 degrees. And this is basically how we are doing the calculation for the vectors.